Welcome to Building the Future. I'm your host, Kevin Horick. You can check out new episodes of the show every Tuesday and Thursday at 2 p.m. If you missed an episode or want to get more information about the show, please visit buildingthefutureshow.com. Welcome back to the show. Today we have Giovanni Vigna. He's a professor at UCSB and CTO at LastLine. Giovanni, welcome to the show.
Thank you for having me.
Yeah, I'm excited to have you on the show. I think what you do and have done kind of in your past is very much relevant to kind of the space and time that we're in right now. But maybe before we kind of get into that, let's get to know you a little bit better and start off with where you grew up.
Right. So, of course, as many might have guessed from my name, I'm Italian. I was born and raised in Italy. I moved in 97 to UC Santa Barbara for a brief postdoc. 20 years later, I'm still there. Obviously, I like the endless spring and beautiful sea that we have here. So I decided to stay as a stable part of the Department of Computer Science. I have a sort of like a weird upbringing. My PhD is actually in electronic engineering, but I've always been interested in security, ranging from the very early virus analysis, very early intrusion detection systems. And so I came to Santa Barbara actually to do network intrusion detection when it was a cool research topic 20 years ago. Sure. Nowadays, it's considered fundamentally a solved problem, largely. But I've been, my field in research is security, and it has been security this whole time.
Sure. So was there like a defining moment that you can remember that got you kind of passionate about that field, or just kind of grew naturally as kind of the internet came to be and you were kind of just, online and dealing with computers?
No, absolutely. I can tell you exactly the moment.
Sure.
I was at home. I was editing .com, not a domain, but a .com object is the version of Windows executable that was before the exe format. And there was no documentation in Italy on that stuff. I kind of figure out how the control flow, what would happen, and I modify manually the binary code in the file to jump to a routine that I injected in the binary and jump back to the beginning, sort of to test how viruses actually attach themselves to this file. And the first time it worked, I was like, oh my God, I'm going to do this for the rest of my life.
That's awesome, man.
That is too much fun. And the fun part is that at that time, there was no documentation, especially in Italy. I remember going to the IEEE library in Milan and finding English manual with all the documentation of the operating system interrupts. And I was like, this is a treasure. Now you go on Google and you find everything you want. At that time, those moments are tattooed in my brain.
That's great, man. Yeah, I love. It sounds like we're similar in that way, where I love almost just like when you have some sort of obstacle. It's usually online or something, and I think the best example is just like I live in Canada, for example, and there's certain things that you can't get in Canada, just like streaming services or whatnot. And they're obviously trying to. I know nowadays there's like VPNs, and it's pretty easy to get most things, but years ago it wasn't. And so just like working around something to get something working, to me it's that like rush, right? And you just love that stuff, or at least it sounds like we're similar to that, right? And it's just like this, and especially the first time something works, you're just like, oh my God, this is amazing. So I totally get that. So
also I think that digital security in general has this sort of catastrophic aspect to it, that either it doesn't work at all or suddenly works great. Sure. So that moment where that disruption happens is a huge high.
Sure. No, that's awesome, man. So what exactly is LastLine, and what do you guys kind of do, or what do you do there at LastLine?
Okay, so I am the co-founder and CTO at LastLine. So I started LastLine with two other researchers, Christopher Krugel and Engin Kirda. Christopher is also a professor at UC Santa Barbara. Engin is a professor at Northeastern University in Boston. And so what we have done in our research in past years is to really develop new analysis techniques to identify malware that actively resists being analyzed. You know, somebody calls it adversarial malware or evasive malware. But the basic idea is that malware has reached a point where the first thing the malware does is like, hey, am I being analyzed? Oh, I am. Okay, then I'm going to be all cool about this.
Right.
And so you cannot really see the behaviors that typically you can use to identify a program as malicious. So this is a very hard problem from the scientific point of view. And so we were fascinated by this. We started working on these techniques, and we created portals that at the university where people could submit, executable or web pages to us. We would analyze them automatically using our tools and give them information. And people loved it. Not only was it free, but it was actually working very well.
Interesting.
And so people start asking, hey, productize this. And we're like, no, we have to get tenure and we have busy with research.
Sure.
But eventually the pressure was too much. And so we decided, hey, let's make tabula rasa. Let's start from scratch. And with everything that we have learned by running these tools, they are called Anubis and Webawet, by running this tool, we have learned so much. If we had to begin from zero, what would we do? And LastLine is the product that is the result of this endeavor. And what we do, fundamentally, sorry for the long-winded answer,
no, it's
but
good,
fundamentally
what
we do, fundamentally what we do, we sit on the network, imagine we sniff the traffic, and we either identify evidence of malware talking to their command and control, so calling home, or if we observe a download or some JavaScript passing by on the wire, we can grab it, send it to an analysis system that sort of like pretends to execute him in a host, and then extract sort of like a score from 0 to 100, where 100 is super bad, 0 is super benign, and then all this information is put together and presented to the user. So you open our product interface, and it tells you these five hosts in your network are infected with WannaCry. This is why we're absolutely sure that this is the case, and this is how they all relate to each other, and this is all the activity that they had.
Okay, interesting. And you have some huge brands using you guys already, but I'm curious to know, okay, so you're sitting, your software sitting on the network and it's watching traffic, like you just said. What happens when it detects something? Does IT or something get a notification, or walk me through that process?
Yeah, so there are different configurations possible. Let's say that in the most non-intrusive configuration, we are just passive observers. Okay. So we just watch what happens in your network. We're not going to prevent anything from really going by. It is the most sort of like non-intrusive. We detect something, we can send an email, we can send a text message to the IT person and say, hey, fundamentally that machine is 100% compromised. Just go there with whatever firepower you have, re-image the machine, do something about it, cut it off the network. It's up to you.
Sure.
Of course, on top of this, we can have different level of reaction. That could be blocking the connection. It could be, for example, going to a firewall. We have integration with various firewalls, and we can say block this from continuing. We can send events to what we call CM, that is aggregators of events. There are many things that you can do on top of this. Of course, the best thing is to prevent the thing from happening. And for example, with email, we can take away the attachment and say, this Excel file is actually full of malicious stuff, and we're not going to get it through.
Okay, so you even just block, because you just block things before it even gets to the user. Because I think the average person just assumes that everything's fine, right? And I don't mean that in a negative way. It's just people just almost, it's one of those things like people don't think it's going to happen to them, right? And
exactly.
And malware is getting really, really smart that a lot of times you don't even know you have it for for days, months, sometimes even years. At least in my experience, I've found some people just don't know until, it's been years, and then they're like, why is my computer so buggy or glitchy? And you're like, oh, you have tons of, adware and malware and stuff like that. So I totally...
Absolutely. I mean, yeah.
No, keep going. Sorry, go ahead.
No, I mean, this software really takes advantage of exactly this kind of attitude. And that's why, for example, ransomware is so effective, because people don't back up, because they say, hey, well, it's not going to happen to me. I know, I don't care. I don't have anything to hide. And then suddenly ransomware comes, encrypts all their kids' pictures, and you're like, yeah, well, I want my kids' pictures. Well, it's $300.
Sure.
And they end up and they have to pay. So this attitude that a security incident will not happen is just the wrong attitude.
So along those lines, in kind of the ransomware stuff, and there's been kind of a bunch of it lately in the media, what's your kind of take on that? Because like I kind of have mixed feelings about it, to be honest with you, and some people blame the corporation that created the software, the hardware, both, and then there's other people that are kind of saying, you know what, like, they told you, they warned you, it's been a number of years now, you can't expect somebody to support something that's decades old. And the analogy that I like to use in an argument when I'm trying to defend the position of you need to update is, like, obviously when you bought a VHS player and then DVD came out, you can't play your DVDs in your VHS player, and you can't play your VHSs in your DVD player. Like, technology just moves on, and you need to upgrade, right? And the internet, Absolutely. At least in my opinion, seems to be one of, if not the only medium where people expect it to be updated for infinity, and their oldest stuff should work till until they decide to update, where any other thing in the physical world doesn't play like that. And so I'm curious to know your thoughts on that kind of whole kind of topic. Where do you kind of see it playing in the actual security space like you guys do?
Yeah, that's a great question. And sincerely, in this particular case, and I mean, we don't have a LastLine position on this.
Sure.
I can tell you my personal position on this is that I don't think that Microsoft is to blame for this.
Sure.
Sincerely, they even put up a patch for that problem.
Yeah,
People
I agree with you.
Install the patch. And so there are two aspects. There are the users of the operating system that don't want to make the effort, or they decide to not invest resources in upgrading to new platforms. And I understand if you're using Windows 7, you don't have to have the latest and greatest. But Windows XP, come on, that's a pretty... People have been warned and rewarned and warned again that they need to update, and they didn't. And also, they didn't want to invest in putting in the sort of the money to pay for the support contract to receive the security patches, even after the operating system became obsolete. On the other hand, and I think that this is even worse. There are some manufacturers, for example, of medical equipment that use Windows XP as their embedded system, quote unquote,
totally.
And do not care absolutely about the security of their system. And there are horror stories. If you look at Kevin Fu, is a professor that specializes in analyzing medical devices and their security. He has horror stories about, drips that can be secure shell into and other ridiculous things that are absolutely obscene from a security point of view, because here we're talking about affecting the livelihood of human beings. I mean, they could die if the drip stops or goes crazy. So I think that we have to understand that everything that is computer operated is a node of the internet. You might think it's not a node on the internet, but your Fitbit is, your heart monitor is, your X-ray machine, because you cannot design this sort of equipment thinking that will never be on a public network, because they will. And I think it's negligent from the manufacturing point of view to put out, I don't know, a morphine drip with Windows XP without any patches, without any protection. So this is, I think, the responsibility stays in people that didn't want to invest in upgrading and manufacturers that ship the devices with vulnerable code on it.
Sure. No, I 100% agree with you. And to be fair, I agree that it's not, at least in my opinion, that it's not Microsoft's fault. It's like they gave everybody more than enough time to do this. And so it's kind of like, well, sorry, like it's your own fault, right? Like so I get it. So I'm curious then, if somebody is running an older version of something, is there anything that you guys at LastLine can do, or is it very much like you need to patch XP and there's not really much you guys can do, or can you do a little bit, or is it just too old and outdated to do anything?
Well, I mean, what LastLine can contribute is to give a very early warning on these, attacks against these obsolete platforms. Actually, the part that does the computer analysis, we call it Sandbox, in our case is able to handle Windows XP, Windows 7, Windows 10. So it covers all these different, platforms because they are out there.
Sure.
What I would say is, like, if you have Windows XP, make sure that your firewalling works well and you have open only ports that you absolutely need in order to deliver the service you're delivering. Sure. Most of the time, the problem is not only in the operating system be unpatched, it's also being unpatched and insanely open.
Sure.
So that is the problem. The composite, the perfect storm is having an obsolete, vulnerable software, but also have its network being completely open to anybody. I mean, there are things that can be done that would completely prevent this from happening.
No, that makes a lot of sense. I think that makes the most sense to me. So you kind of have an enterprise version, you have an analysis program, and then a detonator kind of thing. So how do those three products kind of play together, and how do they kind of work for you guys at LastLine?
Yeah. So this is, I would say, imagine this is three configurations of the sort of same basic capability. So what do? We analyze stuff. We analyze it, and we give you sort of view on things that you would otherwise not see. Okay. So in the case of enterprise, our visibility is into your network traffic and all the artifact, program, documents, and things that are exchanged on your network. So it's the most comprehensive microscope that you put on your network. It will look at all sorts of events, from email to HTTP connections to file transfer, and put this all together. For some people, some people came to us and say, hey, I don't need that. I just wanted you guys to become like an oracle. So I come to you, I give you a file, and you tell me, this is good, this is bad. This is bad, and it does all these different things. So this thing is sort of what we call the analyst. So it's only the program analysis part of our solution that some people use separately. Mostly, for example, analysts in a bank. Oh, somebody come to them with an executable. Hey, we saw, some machines in this other branch being attacked by this. What does this program do? They put it into LastLine Analyst. We unravel this malware. We extract all the behavior, all the registry key, and they're able to say, oh, look, if you ever find something that touches these registry keys, goes and talks to these IP addresses, it's bad stuff.
Gotcha.
It's called indicators of compromise.
Got you. So,
but now, suppose you want to do this at scale for thousands and thousands, then you need detonator. Gotcha. Detonator is fundamentally, you can do a data center that just answer the same question for millions of files every day.
Got you. Okay. That was going to be my next question to you. But so you guys recently won a couple awards at the IT World Awards. What exactly were those for?
So, good question. Well, I mean, it's like most innovative. I think I have to remember. I don't have it in front of me, but it was about innovation and sort of like having an effective solution. And in this, I want to go back to the fact that three of the founders are three professors that are active, very active in the research world. Is that I think that only companies in the security field that have in their DNA academia and research can keep up with a threat that is in continuous evolution. So my internal mantra or LastLine internal mantra is, innovate to protect. And I really believe in that. I think that, you cannot just stop and say, oh, I found the solution to this problem, because we're not, dealing with a physical phenomenon, refraction or, electromagnetic waves. We're dealing with another human being, a bad guy somewhere who's, looking at us say, they caught me again. I'm going to find a way to get around that or come out with a completely new class of attacks that you've never seen. And this is where being ready to adapt and evolve following the threat model, the threat landscape is absolutely important.
Sure. No, I 100% agree. It's kind of like a cat and mouse game, right? Like you're always kind of chasing and that makes a lot of sense. And that's really cool. So I'm curious, you are, you run a bunch of kind of groups and, you're a program chair and you run a kind of hacking team. Walk me through some of those things that you're kind of involved in that kind of keep you active and, up on top of all this stuff.
Of course. Well, first of all, there is, as I was saying, the academic life. I co-direct the security lab at UCSB with Christopher Krugel, also co-founder of LastLine, as I told before.
Sure.
And we have a very large group of PhD students that do research on a number of topics, from binary analysis, vulnerability analysis, IoT security, privacy in social networks, you name it. We're very active in many fields. And, and as every security group, we develop software, make it open source, but also we publish papers that show what's new, what are the new ideas that come out. The hacking team started because in 2003, we decided to participate in the DefCon Capture the Flag.
Sure.
It's sort of like the world championship of hacking.
That's awesome.
And then we participated in 2004, and then in 2005, with this team, Shellphish, we actually won the competition.
Oh, congrats, man! That's great.
Yeah, I mean that's 12 years ago now, but
sure, it's still cool though.
But almost, it's very cool. Very cool. You get that black badge that you can go back to DefCon without having to pay for the rest of your life. It's very nice. But we have been going back to the DefCon Capture the Flag competition for many years following. And actually, I think we are the team that participated in most DefCon CTFs in the world.
That's awesome.
And what we are as a Shellphish hacking team are a group of students of mine that then became other professors, then got other students, and it's a very open and dynamic group, and we just love hacking together. We love to participate in this hacking competition. Everything, of course, is very legal and very safe because
sure.
I'm responsible as a professor.
Sure.
But it's super fun. It's very enthralling when we were talking about the high of making something work. That's the same thing when you hack into something, you finally find the solution. It's awesome. And one thing that we have been involved in that is very interesting, we have been one of the 7 teams that qualified last year for the DARPA Cyber Grand Challenge, which was the first Capture the Flag competition, all based on artificial intelligence. So there were like seven teams put together a system that is completely autonomous, no human in the loop. And these systems have to get a binary, a program, find the vulnerability, exploit the vulnerability, and patch the binary to protect against the exploit. And so, just because we qualified, DARPA graciously gave us $750,000 in cash, which was very nice.
Sure.
And then we participated in the competition in August, right before DefCon, and we placed third. Okay. And so we won another $750,000 in cash. And so now our Shellphish group is very well funded. We have, very good sushi parties.
Sure, that's awesome, man. Congrats. That's quite an accomplishment to do that, right? And it's quite challenging.
It is very challenging. You know why? Because I think that people don't realize that in this, hacking vulnerability analysis, the human aspect is enormous. I know amazing hackers that can look at a program, the binary code of a program, and say, okay, that's where the problem is. And it would take me, hours to get to the same level. But these guys, train and do that, and they're much younger, and they can get there so fast, and they make all the difference in the world. This CGC competition is like, you cannot have this super good hacker. You have to write a program that is able to do that. And so from that point of view, it's sort of like how you codify the ability of a hacker of finding a vulnerability and exploiting it. And I think it was the first step in a long new direction in research in autonomous, computing.
Sure. And this kind of leads me into my next question. Obviously, at least in my opinion, and it seems to be kind of where things are going, that as more and more things come online and the Internet of Things, and just as we potentially go to self-driving cars instead of driving ourselves around, that becoming kind of a good hacker or white hat hacker is only going to become more in demand than it currently is. And it's already, at least in my opinion, very much in demand. But I think it's going to be almost like one of the most, if not the most popular or most needed kind of job, because, if somebody can write code, or somebody's going to be able to get around that code, right, at the end of the day.
Absolutely. And you know what's funny? That even in the academic world, there are some studies, this year, what were the most sought after positions in academia for new professors? Number one was security. Second one was machine learning and data science. I mean, those are the two, huge topics in sort of like in the job market in academia, but in the job market in general. I mean, I cannot produce enough master, undergrad, and PhD student in security because the competition, among companies to hire these people is insane.
Sure.
I mean, they get out of, the program and they're already making way more money than I do. I was like, maybe I'm in the wrong, line of work.
So I'm curious then, people that want to get into the security field, and obviously you guys run a really good program at University of California, Santa Barbara, but what if people can't necessarily go to your campus and take your program? What should they look for in a program, maybe in their local geographical region?
Oh, that's a great question. And so one thing that I often say, security is finding problems in other people's code. So one thing that you fundamentally have to understand is coding. Okay. The only amazingly good security person is somebody who is able to code, either to find problems in other people's code or to compose tools together to achieve whatever they need to do. And nowadays, the language du jour is Python. If you know Python and you know it well, with very little effort, you can build amazing security solution or a security scanner, or you can use the API of Mechanical Turk and Google Drive to do some amazing combination of stuff. And this is why it is important to first understand that you need to program well. Then the second part, you need to know operating system and networks. Those are two things that you have to understand. because otherwise you don't understand the threat, you don't understand what can possibly happen. And only at that point, once you know how to code, how an operating system works, and how networks work, you're ready to look at first basic security training and then advanced security training. I feel that many people come to me and say, I don't know anything, I want to become a hacker. It's like, that doesn't work. Unfortunately, it's sort of like somebody going to a dojo and say, hey, how do I get blue belt right away?
Sure.
Right, well, you don't. You get the white belt, and then the yellow belt, and then the orange belt, and then the green belt, and then you get the blue belt.
But I think that's really good advice, right, in itself, because you're right. It's kind of for lack of a better term, it's kind of trendy right now to either kind of be good or bad in the hacking space, right? And so you, to your point, I think that's really good advice, because you could download software that does things that are written by other people, but you don't really understand. And that's even just outside of the security space. There's lots of software that people use on a daily basis that somebody else wrote, that they just kind of click the buttons in the interface and they have no idea what's really happening. But yeah, I'm curious, you mentioned a programming language, and I get asked this all the time. What programming language do you recommend people learn if they want to get into the security space? Or does it not really matter? You just need to understand how to program?
Well, I mean, I was mentioning Python as a scripting language is definitely the best language that one can learn nowadays to be able to, enable his idea to become systems and to function in the real world. There is a ton of support for all sorts of things, but it will come the day where if you're truly embedded in security, that you want to develop something that needs to be developed in C or Java. So I would start with Python, but one has to understand how programs work in general, the concept of memory organization, how object orientation works, down to how compilers actually end up taking source code and transform them in binary code. But that's advanced. If I would say a first step to fall in love with programming, because I think that if you start programming and you like it, eventually you will fall in love with it.
Sure.
Python is a good start because it's simple enough, but it's also very effective.
Sure. So I'm also curious, what's your daily operating system that you like to go to? Is it Linux? Is it Mac? Is it Windows? Do you not really care which one you use? I'm just kind of curious.
I'm actually, I'm a dual. I mean, I always have, I have a Mac.
Okay.
And I use Mac OS X for sort of like mail, calendar,
sure,
sort of browsing. But all my development work is on a VM with Linux. I use Ubuntu Linux for fundamentally everything that is security related.
Sure. And to be honest, I kind of figured that was going to be your setup, but I was curious. And so for people that don't really understand why you'd pick that configuration, why is Linux kind of so important in the security space, or just even kind of in the developer space?
Well, I mean, I think that Linux has a more, I would say, predictable behavior in terms of network capabilities and things like that, but also has it is more built to be used remotely without a user interface. And all I say now is, made not true, but, the latest development in Windows. At this point, I think Windows and Linux, in terms of capabilities, are fundamentally the same. But, a lot of security people grew up with Linux, and so now they're used to that way of doing things. And also, Ubuntu is free, and you don't have to pay for it. You don't have, weird licenses and things that you have to keep up. And so from that point of view is a better, more open platform.
Sure. And so for people that are kind of looking to get into the space again, how important is kind of learning the terminal? I've heard that kind of come up a few times in these talks. Is it still very important, or is it kind of you can get away with not really learning it?
No, it's super important.
Okay, that's what I kind of figured.
Yeah, and the terminal is back with a vengeance because
Sure.
now, the ability of scripting stuff or performing things on large scale, being able to, have an idea and then throw it in the cloud and being able to use all kinds of scripting techniques to manage, possibly for a few minutes, few hundreds hosts and then shut them down. All this is not something that you can do with a graphic user interface. Being able to script stuff and use the terminal is a fundamental skill.
Sure. I 100% agree with you. And the thing that I find, like, I use it, but I don't consider myself like an advanced user. I know enough to get around and do some things, and I'm more on the design side anyway, but I do understand. But the thing that I find always fascinating to me, and I've worked with guys that really know the terminal, and they can do anything faster than you could ever do in a GUI. Like, I used to work with a guy, he literally just had like 12 terminal windows, and he ran a Dvorak keyboard on this like optimized programming keyboard that where his thumbs were the space bar, but they were his index fingers were the space bar, and like it ran Dvorak, and so you had no idea how to use that thing. But man, could that guy just like fly in the terminal, and he could do anything, like from coding to Git to, deployment to running scripts. And it was just, and so why I wanted to bring it up is because I think, to your point, it's coming back with a vengeance, but I think a lot of people, especially sometimes developers that maybe want to get into the security space, aren't spending time learning the terminal kind of properly. And I think it's super important.
Yeah, absolutely. You cannot be more right. I think that, and user interfaces have their place. I mean,
sure.
they're great to show graph and data, but for me, there is nothing like the control and repeatability. So you can script stuff, you can set up cron jobs that run at specific times. You can do so much more. So that's a very, very important tool.
No, I 100% agree. So I'm kind of curious, you're obviously a professor and you're doing a startup. How do you kind of balance working full-time and teaching, which by full-time, I get that, you don't work 9 to 5, right? Like you might teach 9 to 5, but you have stuff that you're involved in a bunch of extracurricular stuff. You're running these events, and you're doing these groups and these hackathons and all this stuff. Plus you're running a company. How do you kind of manage all that, and kind of what have you found that's kind of worked for you and, hasn't really worked for you when you're trying to balance this kind of startup with or company life with kind of, running an academic life?
That's you've been talking to my wife, obviously. So I think it's a balancing act, as you said. The good thing is that the things that I see in the company world, the real world, oftentimes are a suggestion for great research ideas. And vice versa.
Cool.
And vice versa, things that I see in the research world, I might like, oh my God, I wonder if this would work, in an industrial setting.
Sure.
So there are two very different worlds. One, it is driven by what's novel. I mean, in the academia, they don't care if it scales to the internet or if it can be user-friendly. They just want the new algorithm goes faster, better, more effective. And oftentimes cannot really be applied to the real world because it wouldn't scale or it wouldn't be fast enough. But it's interesting nonetheless.
Sure.
By the same token, in the real world, you find, problems that, I to give you one example. I was talking to somebody, say, we have to manage all these different machines, and sometimes they're all configured exactly the same. So for us, we notice that something is wrong with that because they all behave the same, and then this guy is an anomaly. And it's like, wow, it would be interesting if we can sort of create like a mapping of the kernel memory layout of all these computers that are supposed to be the same, and use some kind of graph algorithm to compare them and find out which has been infected and which not. And we did, and we had a system called Black Sheep that does exactly this. And this is something that, talking to somebody became an interesting research problem. But it takes a toll. Being, leading a hacking team to being an academic and also being in the industry, a CTO of a company, let's say that there is not a lot of free time.
Sure. No, and I love that honest answer, right? But I also love how you use kind of both of them to feed the other one, because I think that also keeps it interesting and fresh.
Absolutely.
And to your point, I think it's interesting how obviously a lot of the stuff that you're researching is probably on the very cutting edge that you can kind of move into the product. And then when somebody comes to you and says, yeah, I have this problem, you can move it into the research side and kind of explore that, right? And see how that plays out. That's really cool, man.
Yeah. It's fun stuff. Sure. I tell you, especially security. I mean, it goes back to having that, the problem you're trying to solve is a bad guy somewhere,
Sure.
Millions, but thousands of miles away. That keeps it fresh. I mean, new problems come out. I mean, you were mentioning the Internet of Things. I mean, that's something that we're looking at, understanding how, all these objects that per se are just yet another host on the Internet, but now they're talking to each other, they're interacting with the physical world. It's very exciting time.
Sure. So I'm kind of curious, where do you kind of see the future of kind of security going? Or is it kind of the unknown still a little bit? Like, how do you, I guess, kind of stay on top of the hackers and kind of where do you see this all kind of going?
Very, very good question. I think that there are going to be two fundamental trends. One is a continuous and more ubiquitous cloudification of everything. I think we'll stop having our own platforms, and we're fundamentally going to have just windows or browsers. So like little, viewpoints on whatever happened in our personal cloud up somewhere. This is an obvious evolution that also has security implications. On the one hand, it becomes easier to protect people, because if I am in control of your operating system and I update it every 15 minutes, it's a lot harder to break into it.
Sure.
But also it will become more data will be out there, and the guys who are now targeting your computer, your platform, will start pointing their weapons towards the cloud itself.
Gotcha.
And imagine finding one flaw on Dropbox and being able to, access every Dropbox folder. Now, sure. The stakes are up. I mean, it's going to be incredibly hard to find these bugs, but once you find them, we're talking about, catastrophic data leaks and things like that. So I think that's one of the trends, and that's why, for example, our solution also integrates with cloud services. So you can have, email in the cloud. We'll analyze your email anyway. Don't worry. I mean, we're gonna integrate with those, platforms. We do integrate with those platforms as well. The other thing is sort of like I think there's going to be a lot of merging between what we saw as the opportunistic cybercrime. So sort of the financial, stealing your data, cloning your credit card, a little bit of ransomware, and this will merge with sort of like nation state attacks.
Okay.
And we already saw something where, for example, there was an article in the New York Times that was describing how the Russian intelligence went to a cyber criminal who had a botnet and say, hey, you have a few 100,000 bots around the world. Can you look for these keywords for us? And suddenly something that was, a botnet, a financial steal your money, sell it on the dark web type of thing, became actually an intelligence tool for a nation state. And I think we will see more of this, to the point that it will be impossible to say, oh, I don't care about, ransomware or adware. I only care about the nation state stuff. Well, guess what? The nation state now is piggybacking on this very, if you want run-of-the-mill malware. And so you need a platform or protection mechanisms that are able to cover all the spectrum.
Sure. No, that's actually really fascinating. So I'm curious though, does voice commands to like something like Home or Amazon Echo, does it make things more complicated for you? Does it stay the same? Is it different?
I think it's different. Imagine we always talk about this new IoT thing. Imagine that you have a video sort of like in front of your door, a video bell, whatever that, so, and suppose that it goes automatically when you press a button, and suddenly from the door you can shout, Alexa, open the door, and suddenly the door opens. So we're not used at understanding what are the interaction between these different components in the cyber physical world. We understand Zigbee, we understand TCP/IP, these protocols that are used by these devices to interact with each other, but that suddenly you have that if you raise the temperature in this room, this light would go off, and suddenly there is a sensor that will do something else. There could be unintended interactions, and we're not very good yet at understanding the implication of these things.
Interesting. I kind of figured that you'd kind of go that direction, because you're right. Like it's so new, right? Like this stuff's only a couple years old.
I'll give you an example. Have you ever heard about ultrasonic tracking?
Yeah.
Yeah, but you know how few people heard about that?
Sure. So what is it for people that don't know?
So fundamentally, it is a way to you install something on your cell phone that is an ad framework. You install it as part of an application, and this application actually on your phone is listening in the sort of like very high frequency that you cannot hear. Maybe a dog can hear it.
Sure.
And suddenly you're in front of a website or in front of a TV, and that website start playing some ultrasound beacon that is captured by your phone. So I know who is in front of this web page this very moment. I know who is in front of this TV station listening to this ad in this particular moment. It's a way to track people using ultrasound that we are completely unaware of and can be a violation of privacy.
Sure. No, that's quite fascinating. But sadly, we're out of time. So maybe let's close the show with mentioning where people can get more information about yourself and LastLine.
Yes, of course. They can go to our website, www.lastline.com, or they can just, Google LastLine and Google my name, and they will be on their way to finding a lot of information. They can also Google Shellphish with a PH, so Shell, PHISH. That's our sort of hacking team, and there is a lot on the internet about that. So always Google it. It's a great starting point.
Perfect. Well, I really appreciate you taking the time out of your day to be on the show, and look forward to keeping in touch with you, and we'll talk soon.
Thank you for having me. It was really a fun conversation.
Thanks, man. Have a good rest of your day.
All right.
Okay, bye.
Okay, bye-bye.
Thanks for listening. The music for the show is done by Electric Mantra. You can check them out at electricmantra.com and keep building the future.